So we're going to be using graphs of parabolas to be able to solve quadratic equations and inequalities. Okay. Um, the first thing you need to know is this little paper that I have posted on the wall, that the answers to a quadratic, the answers of the solutions, they're the same thing as the x-intercepts of a parabola. Okay, the answers are the same thing as the x-intercepts of a parabola. And for future reference, how do you find the x-intercept? You set y equal to 0 and solve, right? So we're going to be able to solve a quadratic equation or a quadratic inequality by looking at the graph of the parabola and focusing in on the x-intercepts. So on your graph paper, go ahead and graph this first one. Let's start this together. In order to start graphing this quadratic trinomial equation, you're going to start with the vertex. The vertex, you're going to use the vertex formula, negative b over 2 times a. And of course, when you use a formula, you're going to do negative parenthesis over 2 times parenthesis. Replace the b and the a with parentheses. That way, when you identify your a value of 1 and your b value of 6, it's really easy to see that you plug in the 6 up on top and the 1 on the bottom. So our vertex x value is really negative 6 over 2 times 1, that's 2. So our vertex x value is really negative 3. So x equals negative 3, and we're talking about the vertex. That's the x value. How do you find the y value? You simply plug it in. Plug it into where your x's are at. X is negative 3, put a negative 3 right there. X is negative 3, put a negative 3 right there. So you're going to rewrite it, but with parentheses. Instead of x squared, I put parentheses squared plus 6 times parenthesis plus 5, and we simply insert the x value of negative 3 where the x's used to be at. And then you could do this all on the calculator, or you could do it by hand, thinking, what is negative 3 to the second power? That's positive 9. And then how about positive 6 times negative 3? That's a negative 18. And of course, you could bring down the plus 5. And when you go from left to right, 9 take away 18, that's negative 9, and negative 9 plus 5, that is negative 4. So we just found the y value of our vertex, negative 4. Are you with me? Let's plot that most important point, negative 3, negative 4. By the way, you don't have the same exact graph that I have. You have I think a 7 by 7. I have an 8 by 8. Okay, so it's not going to be exactly like mine. But just go to your location, negative 3, negative 4. Put a dot there. And now from that dot, I need more points. I need more dots. So I'm going to use the pattern that I asked you to memorize, 1, 1, 2, 4, 3, 9. I could use that pattern because the a value is 1. You don't have to modify it. So you're going to go 1 to the side and 1 up because the a value is positive. So 1 to the side, 1 up would be right there. Back to the vertex, 2 to the side and 4 up, 1, 2, 3, 4 would be right there. And then 3 to the side, back to the vertex, 3 to the side, 1, 2, 3, and 9 up, 4, 5, 6, 7, 8, 9 would be right there. And of course, through any vertex, there's an axis of symmetry, and you could reflect it to the other side. So you have a dot right there, and up here. So we can now graph our parabola. Simply connect the dots. Maybe I should have used a different color. Yeah, that's not good. I'm using black. Whatever. There's our parabola, okay? We all should know, we all should be pros at graphing parabolas. We're good with that, right? Okay, now, what if I would have said, find the x-intercepts? Algebraically, you would set y equal to 0 and solve. And what are our x-intercepts right here? Our x-intercepts are at negative 1 and, so right, negative 1, negative 2, 3, 4, 5. So negative 1 and negative 5. Those are the x-intercepts right there and right there, negative 1 and negative 5. So our answers, the x-intercepts are negative 1 and negative 5. So if I had this as an inequality, not as an inequality, as an equation that's set equal to 0, and I asked you to solve it, if I asked you to solve it, your answers would be those x-intercepts answers, negative 5 and negative 1. Those are your two answers for this one equation, okay? And in the future, we're going to be solving using the quadratic formula. But right now, I want you to understand that the x-intercepts really are the answers to the equation, okay? Let me prove that to you. If I put a -5 right here, -5 squared, -5 times -5 is positive 25. If I put a -5 right here, 6 times -5 is -30. 25 minus 30 is -5. -5 plus 5 really is 0. That's an answer for sure. Plug in the -1 right there. -1 times itself is 1. How about a -1 right here? 6 times -1 is -6. 1 minus 6 is -5, and -5 plus 5 is 0. So both of those are the answers. But we already knew that. Why? Because the x-intercepts are the answers. Do you get it? So when you graph your parabola, you technically are not even looking at the whole thing. All you're looking at is the x-intercepts. On the x number line, what part of the x number line is the parabola on? Oh, it's at -5 and at -1. So your answers are x equals -5, x equals -1. Why? Because the answers are the x-intercepts. The x-intercepts are the answers. So let's try one that has an inequality involved. So go to your next graph and go ahead and jot this inequality right here. As you can see, it's the same inequality as it's not the same inequality, it's the same graph as the one above. Okay, it's the same graph, but this time it's an inequality instead of an equation. So you're going to have the same vertex. What's the vertex on the above one? -1, 2, 3, -1, 2, 3, 4. If you graphed it doing the same method, right? 1 to the side, 1 up, 2 to the side, 1, 2, 3, 4 up, and 3 to the side, 9 up. Or you could just say, where would this parabola cross the y-axis? That would be your c value of the standard form. So that'd be at 5, 1, 2, 3, 4, 5. Of course, map it over the other side of the axis of symmetry. It'd be right there, right there. It's the same exact graph as the one we just did. But right here, we're not going to draw a solid parabola. Why not? Because it's an inequality that does not have a solid line underneath it. So there's going to be a dotted parabola with arrows. And now we either have to shade above or below. And you got to look at your y, and it's greater than. So greater than on the y, is that above or below? Above. So you're going to put your pencil on the parabola itself and shade above, which is going to be technically on the inside of your parabola. So you shade above, which is on the inside of the parabola, not on the outside. So if you understand how to graph this inequality and shade the parabola on the inside, which is above, then you should be able to find the answers to this guy. Okay. So what's the difference between this and this? It's the same exact thing. Like imagine this, if I told you, find the x-intercepts of this. How do you find the x-intercepts? You set y equal to 0. So you'd have 0 is greater than that stuff. All I did was take the 0 and put it on the other side, but it has to stay greater than 0 greater than that stuff. So over here, 0 is on that side, it's opening up to the 0, 0 is greater than that stuff. Does that make sense? Okay, so if I were to solve this thing, then my answers would be the x-intercepts. However, it's not just this point and that point like the previous graph that we did. Right here, we have a highlighted area that's between here and here. So if you focus in just on the number line and you have at -5 and at -1, these are technically open dots. Why open dots? Because the parabola is not solid and the area is shaded inside those two dots. So this is technically going to be a compound inequality written together because the areas are together. So my answers are going to be -5, -1, x is in the middle, in between, with less than symbols. This is my answer to this above inequality. So we didn't have to really do math. You graph it and then understand that this guy is shaded between the -5 and the -1. The area is between it. So it's a compound inequality, smaller number on the left, bigger number on the right, x in the middle with less than symbols. Smaller, bigger, x in the middle with less than symbols. So if you understand that it's a compound inequality written together, that's great. But then again, it's our first one. So let's do a couple more here. Um, Copy this one down on your next graph. So let's start by graphing this guy by finding our vertex. To find our vertex, we're going to use a vertex formula, x equals negative b over 2a. And when we use the formula, replace it with parentheses. And then, of course, you could identify your b value, which is 2, which goes right here, and your a value, which is 1, which goes right here. So you really have the x value of negative 2 over 2, which is really negative 1. So the vertex x value is negative 1. How do you find the y value? Simply plug in the x value of negative 1. X is negative 1, and we're talking about the vertex. So let's plug it into x squared plus 2x minus 3, and plug in the negative 1 and the negative 1. And then you do the math all on a calculator, or you could do it by hand. Negative 1 times itself is positive 1. 2 times negative 1 is negative 2. Don't forget about the minus 3. So when you go 1 minus 2, that's minus 1, and 1 minus 3 is minus 4. So your vertex is negative 1, negative 4. So let's graph negative 1 on the x, negative 1, 2, 3, 4 on the y, put a dot there. Of course, you have an axis of symmetry going right through it. Could somebody tell me the y-intercept of this parabola? Negative 3, that's simple, right? 1, 2, 3, negative 3, whoops. Of course, you could map that over to the other side. But then again, the a value is positive 1, which means we are going to be using the pattern 1, 1, 2, 4, 3, 9. So yes, we have 1 to the side, 1 up. Then you go 2 to the side and 4 up. 1, 2, 3, 4. Whoops. You go back to the vertex, 3 to the side, 9 up. And it's going to be up here. Yours is probably going to be 1 off the graph. Mine's going to be right here because I got a slightly bigger graph than you do. So yours is probably 1 unit off the graph. Or did I do that wrong? I did that wrong. It's over here. My bad. 1, 1, 2, 4, 3, 9. Okay. Map it over to the other side. You have a dot right here and over here. Now, before we graph this, we understand that this is not a solid parabola because it does not have a solid line underneath it. So you're going to do a dotted parabola. And you either shade above or below based on your inequality. Y is less than, that is below. So you got to shade below. So you put your pencil on, let's say, the vertex and shade below. Are you shading the inside or the outside? Shading the outside. So you're going to shade below, shade below, shade below. So you're technically shading everything that's on the outside of the parabola. But the only way to conclude that is by understanding above or below based on this inequality. Y is less than, that's below on the Y. So now we've graphed it. You understand how to graph it. Now let's interpret what the actual answers are. The answers are the x-intercepts. If I said find the x-intercepts, you'd have to set y equal to 0, and you'd end up with 0 is less than that stuff. But let's write that stuff first and say that that stuff is greater than 0. That's what it says over here. That stuff is greater than 0. Okay. Now, if you were to solve this, then you got to represent your highlighted areas here. And your highlighted area is the x value of 1, and it's highlighted to the right. And the x value of negative 1, 2, 3, negative 3, and it's highlighted to the left. So it's technically two inequalities that are separate with the word or. So your answers are going to be x is less than negative 3 or x is greater than 1. It's two separate inequalities because it's highlighted to the left and to the right. If they would have been highlighted together, then it'd be a compound inequality written together. But because these areas are apart, you keep the inequalities apart with the word or between them. Does that make sense? Okay. So here's another one. However, this other one, I left it in vertex form, so it'll be a lot easier to graph. Okay. So imagine this. I tell you, solve this inequality. Yes, you could do algebra to solve and see what your x values are. You'd have to add 2, divide by 2, divide by 2, do a square root, subtract 3. You got a plus or minus. There's a lot of work to do algebraically. But if you think about this inequality, it's technically in vertex form. Your a, x minus h, close parentheses squared plus k. And this is a 0, which is technically a y. because if I asked you to solve an equation, it'd be the same as finding the x-intercepts, and finding the x-intercepts would be setting y equal to 0. That's why there's a 0 here. So technically, there's like a y right there where the 0's at. And if you wrote it the other way around, y greater than this stuff, it would be exactly this. Y is greater than that stuff. So this is the equation that we're using to graph. What's the vertex? You could just see it because it's in vertex form. Think opposite on H, take K for what it is. What's the vertex? That's right, -3, -2. So if we go to -1, 2, 3, and -2, you put a dot there. That's the most important point. You have an axis of symmetry running right through it, which will provide a reflection. And is this opening up or down? It's opening up because the A value is +2, but we can't use the pattern of 1, 1, 2, 4, 3, 9 because we need to modify it according to this new A value of 2. So times 2 times 2 times 2. So your new pattern is not 1 over 1 up, it's 1 over 2 up, 2 over 8 up, and 3 over 18 up, which you're not even going to be able to use. But if we go 1 over and 2 up, you're going to end up right there on that x axis. And if you go 2 over 8 up, well, 2 over and 8 up, 1, 2, 3, be right there. You would be 1 unit off the edge because yours is 1 unit smaller than mine. And of course, if you map them over to the other side, you'd be right there and right there. And if you thought about this parabola, is it solid or dotted? It's obviously dotted. And is it shaded above or below? You got to look where the y is at by itself. Y is what? Y is greater than, so that's shaded above. Hopefully you're getting this. So you shade above, which means that you're shading the inside. Yay? So what does that mean? If I wanted you to find the answers, or if I wanted you to solve this thing, you got to look specifically at the x number line itself. And where are these x-intercepts at? It's at -2 and at -4. And the areas are together. So you technically have like an open dot right here, open dot right there, and the areas are together. So because the areas together, where's it highlighted? It's between the -4 and the 2. That's what we have to do. We have to write this as a compound inequality written together. So you'd write this as a -4, -2, x in between it with less than symbols. This is your compound inequality answer. How does that taste? I hope you get it. Question? No questions. All right, let's move on. Special cases. Okay, so this one is in vertex form, but before graphing it, I would like you to think, where's my y at? You see, in order for you to find the x-intercepts, you would set y equal to 0. So you have a 0 here. So that's technically like it used to be a y. Just put a little y up there. Okay, so if you were to write this the way you normally would, you would have the y on the left side. And of course, if it was opening up to the y, it has to continue opening up to the y. So if you flip it, you technically have to flip that inequality to make it continue opening up to the y. And now you have the 3 parentheses x minus h close parentheses squared. There is no k. You could put a +0 if you want, but it is in vertex form. What's my vertex? 2, 0. Great. So go 2, 0, put a dot right there. Now is this opening up or down? Up, because the a value is positive. That means that we have to modify the pattern 1, 1, 2, 4, 3, 9 according to this new a value of 3. So you're going to multiply by 3, multiply by 3, multiply by 3. So instead of 1 over 1 up, you're going to go 1 over 3 up. Instead of 2 over 4 up, you're going to go 2 over 12 up. So let's just go 1 over and 3 up. So 1 over and 1, 2, 3 up, it'd be right there. If you mapped it over to the other side of the axis of symmetry, it'd be right there. Is this a solid parabola or a dotted parabola? Solid, because it has a solid line underneath it. So you draw a solid line on your parabolas, on your parabola, and then you either shade on the inside or the outside, which you got to think of above or below. Above, which technically means you're shading the inside of the parabola. So we're going to shade the inside of the parabola. Okay, so if I'm solving an inequality, the answers are the x-intercepts. And yes, before we would have like a highlighted area between here and here. It was highlighted between, so you had to write a compound inequality, or maybe it was to the outside going this way, to the outside going that way. So you'd have two inequalities separated with the word or. What part of your x-axis, what part of your x number line is highlighted? What part of your x-axis is it highlighted over here? Where is it highlighted? Nowhere, right? But this dot does exist. That technically is a highlighted dot because it's a solid parabola. So your solutions include the parabola itself. So in this case, it's not an inequality. The answer is only the answer 2. So x equals 2 is the only value that if you plug in here will give you a true statement. 2 take away 2, 0, 0 squared is 0, 3 times 0 is 0, and 0 is equal to 0. So that's the only value that'll be true. Now, if this parabola would have had the vertex up here and opening up shaded inside, then none of it would be highlighted on the x-axis, and that would be a no solution. Yay? Let's take a look at another special case problem. I don't know if you ran out of parabolas or graphs, but if you haven't, go ahead and copy this one down. I left the 0 on this side. That way you could easily think of y is greater than -2 parentheses x plus 3 squared, and then plus 0 for the k value. So what's my vertex? Think -3, and there is no k value, so -3 comma 0. So go to -1, 2, 3, 0, put a dot right there. Yes, you have an axis of symmetry that goes right through it. We need more points. Could I use the pattern 1, 1, 2, 4, 3, 9? No, I can't. I need to modify it because there's a new a value of -2. So times -2 times -2 times -2. So instead of going 1 over 1 up, I'm going 1 over 2 down. Instead of going 2 over 4 up, I'm going 2 over 8 down. So here's my new modified pattern. And we only need the first part of it. 1 over 2 down. 1 over 2 down would be right here. And you could map it over to the other side. Now, is this one solid or dotted? Dotted. Okay. Do I shade above, which would be on the outside, or below, which would be on the inside? Above. Why? Because that's a greater than symbol. So you shade above. So we are going to shade everything that's on the outside of this parabola. Now, if we're talking about the solutions, we're talking about the x-intercepts, which would be setting y equal to 0. That's why there's 0 there, which means you're only going to be looking at the x number line. So what part of the x number line is highlighted? What part of the x number line is highlighted? All of it is highlighted. It's highlighted at 0, 1, 2, 3, 4, 5, and -1, -2. It's highlighted everywhere, but because this parabola is not solid, there's technically an open dot right here. Does that make sense? So when we're looking at the answers here, this is a special case. Doesn't always happen. This is technically an open dot. And where's it highlighted? It's highlighted this way and that way, which means it's every single number, but it cannot be that -3 because that's the x value that it cannot be because it's not a solid parabola. So you would say x equals all real numbers, but x cannot be -3. What do you think? If you already ran out of graphs, then just watch me do this. This is technically in vertex form. You could easily see the vertex. The vertex is +3. Think opposite on h. Take k for what it is. +3 comma -1. So if you go 1, 2, 3, -1, there's your vertex. However, before I start graphing this, I want to recognize that my y value is where the, or used to be where the zero's at. So if I wanted to go back to the original, I would have y on this side. It would have to still open up to the -x minus 3 squared minus 1. So that way we're correct when we think of either above or below. So this does have the pattern of 1, 1, 2, 4, 3, 9, but it's opening down. So if you go 1 over 1 down, back to the vertex, 2 over 4 down, and you could map that over to the other side right here and right there. This is going to be a dotted parabola. Do we shade above or below? below because it says y is less than. Put a dot on your vertex and shade below. So that means that you're shading on the inside of this parabola. So right here, what part of the X number line is highlighted? What part of this X number line is highlighted? None. So what do we say? No solution. So keep in mind, sometimes you're going to have like the highlighted area between 2 points. You do a compound inequality. Sometimes it's going to the left and to the right. So you do 2 separate inequalities with the word or between it. Sometimes it's only one dot where it just touches and it's a solid parabola. If it's, but right here, none of this is highlighted, so it's no solution. Okay, so we do have a practice worksheet 4.8 WSP. You have 3 of these that they want you to just practice graphing and shading. And this bottom part, I selected these questions that work out pretty nicely when you think about their graphs. In the future, we're going to go back and do this worksheet with the quadratic formula and other methods. But right here, go ahead and circle 4, 8, 9, 10, 12, and 14. And I also want you to practice doing the first 3. So this is a great way to get prepared for Friday's test. Which one would you like to see? 4, 8, 9, 10, 12, or 14? 14 it is. Let's go to 14. Again, I want you to solve this inequality, find the answer by thinking of the graph and understanding the shade according to the x-axis. So let's start graphing this thing by finding the vertex. And the vertex is found with negative b over 2 times a, negative parenthesis over 2 times parenthesis, where your b value is 36 and your a value is 9. So what you really have is negative 36 divided by 18, which is really a negative 2. So far you have the vertex x value of negative 2. I'm working fast because this video is already too long. Hopefully you understand what I just did. Then you're going to find the y value by plugging it back in. 9x squared plus 36x plus 36. And you're plugging in that x value of negative 2 to find the y value. Okay, so when you do the math, you could do it all on a calculator, or you could do negative 2 times itself. That's 4. 9 times 4 is 36, but 36 times negative 2 is negative 72. And when you combine 36 and negative 72, you get a negative 36. But then you bring down this positive 36 and you end up with 0. Yay? So the vertex y value is 0. So even though you don't have a graph, you could just sketch one right here, an XY graph, and go to the location negative 2, 0, and put a dot right there. Now, does this open up or down? Well, check this out. We know it opens up because the a value is positive 9, but keep in mind that the y used to be here where the 0's at. So to make it a little more clear for us, put a y right there where the 0's at, and then flip everything so it looks like you have the y on the left side. So you would have y is greater than or equal to 9x squared plus 36x plus 36. Okay, so it is opening up, but you'd have to modify your pattern. Instead of 1, 1, it would be 1, 9 because you have to multiply by the a value of 9. So if you went 1, 9, obviously it's going to be very narrow. It's vertically stretched, but this is a solid parabola. So think about that. It's a solid parabola. It's thinking super narrow. Do I shade the inside or the outside? Do I shade above or below? I shade above because I have y is greater than or equal to. So if you put your dot on the vertex and shade above, technically you're shading the inside of this parabola, not the outside, right? So when I ask you what's your answer? I'm really asking you what part of the x-axis is highlighted. Is any part of this x-axis highlighted? No, except for that actual location right there, that negative 2, because it does have an or equal to, so it does include the actual parabola. So the answer here is only x equals negative 2. That's the answer. That's the only value that you could plug in right here that'll give you a true statement. Okay. So again, we're going to be graphing, and you're going to be looking at the highlighted area just with regards to the x. We can do another. Which one do you want to do? Anybody? No? Nobody wants another. Come on, people. I'm the one working here. You're just watching. What out of the highlighted ones? 4, 8, 9, 12. 12 it is. 12 is a good one. Why? Because it doesn't even have the zero, right? So what should we do? Let's first get the zero there. Great question. Subtract 8x. Subtract 8x. So you're going to have negative x squared minus 8x minus 15 is greater than or equal to 0. Now keep in mind that 0 is where the y used to be at. Yeah, you have to get the 0 first. And then that 0 is where the y used to be at. So now you could flip it all and put the y on this side, and it would be less than or equal to the negative x squared minus 8x minus 15. I hope you guys already understand that process. I've done it numerous times right now in this video. So replace the 0 with the y and then move it to this side. It was opening up to the trinomial. It has to continue opening up to the trinomial. It didn't open up to the y. It cannot open up to the y. So once it's in that form, then you could worry about getting your vertex. X equals negative b over 2 times a, negative parenthesis over 2 times parenthesis. The b value is negative 8. The a value is negative 1. So you really have a negative 8, which is a positive 8, over 2 times negative 1 is negative 2. That's really a negative 4. Our vertex x value is a negative 4. We still need the y value. How do you find it? You simply plug it in. So we're going to plug it into the one that was set equal to 0. So you're going to have the negative x squared minus 8x minus 15, and we're plugging in the negative 4 right in there. So make sure you do this math either on a calculator or you're very careful, because you have to do the exponent first. You have to do negative 4 times itself, which is positive 16. But that negative sign that's on the outside has to come down in front of it, and it changes it back to a negative 16. And then when you do negative 4 times, or negative 8 times negative 4, that's a positive 32. And then when you combine negative 16 and 32, you get a positive 16. And then you bring down this minus 15, and 16 minus 15 is 1. So we just found that the y value of our vertex is 1. Okay? So we have to sketch it, go to the location negative 4, negative 1, or negative 4, positive 1. That would be right here. Is this shaded above or below? I mean, shaded above or below. Is it opening up or down? I went ahead of myself. It's opening down because the a value is negative, and it is the a value of negative 1. So you could go 1 over 1 down, and you'd be right there on the x-axis. And if you went 1 over 1 down in the other direction, you'd be right there on the x-axis. What are those values? Those values are negative 3 and negative 5. Okay. Now you could continue with the pattern 2 over 4 down, 3 over 9 down. But the reality is that this is a solid parabola that's opening down. That's just a sketch. That's all you need. And then you got to either shade above or below this solid parabola. What do you say? Above, it says less than. Why is less than? What's that? Above or below? Below. So you're going to shade, you're going to put your pencil on the graph and shade below. So that's technically the inside of your parabola. Okay. Now, our answer is going to be the highlighted part of the X number line. So what part of this X number line is highlighted? It's highlighted between negative 5 and negative 3. So your answer is between negative 5 and negative 3. Put X in the middle, put less than symbols. This was a solid parabola. So these are solid lines underneath those inequalities. And there's your answer to this inequality. And of course, if you go to Google Classroom, you'll be able to verify all these correct answers that we have here.